So let us talk about understanding requirements. So understanding the requirements of a problem is among the most difficult tasks that face a software engineer. So what you first think about it, or when you first think about it, developing a clear understanding of the requirements doesn't seem that hard. But after all, the customer don't know what is required. So shouldn't the end user have a good understanding of the features and function that will provide benefit? Right? Surprisingly, in many instances, the answer to this question is no. And even if the customer and end user are explicit in their needs, those needs will change throughout the project. Right? So let us start with the requirement engineering. And in this the broad spectrum of tasks and technique that lead to an understanding of requirements is called this requirement engineering. So requirement engineering, what it does, it actually builds a bridge to design and construction. And requirement engineering also provides the appropriate mechanism for understanding what the customer wants, analyzing the needs, assessing the feasibility, negotiating a reasonable solution, and specifying the solution unambiguously. That is, validating the specification and then managing the requirements as they are transformed into an operational system. It also encompasses 7 distinct tasks which I'm going to speak out. So these are inception, elicitation, elaboration, specification, validation, and management. So inception means ask a set of questions that are established. That means basic understanding of the problem, the people who want a solution, the nature of the solution that is desired, and the effectiveness of the preliminary communication and collaboration between the customer and the developer. Then elicitation. What does this mean? Elicit requirements from all stakeholders. Means it certainly seems simple enough. Ask the customer, the user, and other what the objective of the system product are, what is to be accomplished. So how the system or product fits into the need of business, and finally how the system or product is to be used on a day-to-day basis. But it is not simple, it's quite hard. Then elaboration. Create an analysis model that identifies data, function, and behavioral requirements. Then negotiation. Agree on a deliverable system that is realistic or possible or feasible for developers and customers. Then comes the specification. So in the context of computer-based system, the term specification means different to different people. A specification can be a written document or a set of models, a formal mathematical, a collection of use cases or user scenarios, or it may be a prototype also. Then comes the validation. So the work product, these are produced as a consequence of requirement engineering. These are assessed for quality during a validation step. So a review mechanism that looks for errors in content or interpretation, areas where clarification may be required, or missing information. Also inconsistencies, that is the major problem when large products or systems are engineered. Then conflicting or unrealistic, unachievable requirements, this also comes under validation. Then comes the requirements management. This requirements management is a set of activities that help the project team to identify, control, and track requirements and changes to requirements at any time as the project proceeds. So let us see these in detail. Inception means you have to identify the stakeholders. Who else do you think I should talk to? Recognize multiple points of view and work towards the collaboration, and ask questions such as who is behind the request for this work, who will use the solution, who will be the economic benefit of a successful solution, and is there another solution for the solution that you need. Then eliciting requirement, that means meeting are connected and attended by both software engineers and customers. So rules for preparation and participation are established, and agenda is suggested. Then A facilitator, that can be customer, a developer, or an outsider. They controls the meeting. And a definition mechanism can be worksheets, flip charts, and wall stickers, or an electronic bulletin board, chat room, or virtual form is used. So the goal is to identify the problem, propose elements of solution, negotiate different approaches, and specify a particular set of solution requirements. This is an example of eliciting requirements, and it does say that how to elicit requirement, that is from conducting fast meeting, making list of function and classes, making list of constraint if some prioritization is there, then use QFD to prioritize the requirement, informally prioritize requirement, and then create the use cases. And this is like creating a use cases that define actions, write scenarios, complete template. This is how it is done. Then comes the quality function deployment, QFD. This quality function deployment is a quality management technique that translates the need of the customer into technical requirement for software. So you actually convert the requirement into actual technical requirement. So function deployment determines the value of each function required for the system, and information deployment, it identifies data objects and events, while this task deployment, it examines the behavior of the system, and value analysis, it determines the relative priority of the requirements. Then elicitation of the work products. The work products are a consequence of requirements elicitation that will vary depending on the size of the system or product to be built. So most of the system, the work products include a statement of need and feasibility, like this, a bounded statement of scope for the system or product, the list of customers, users, and other stakeholders who participated in requirement elicitation, and the description of system technical environment. Then a list of requirement and the domain constraint that apply to each, and the set of usage scenario that provide insight into the system of the product under the different operating conditions. And any prototypes developed to better define the requirements is always welcome. Now, actually building the analysis model. There are various elements of the analysis model. First of all, you have scenario based model, that is, you have functional processing narratives for software function, and use cases, that is description of interaction between an actor and the system. So before I go ahead, let me introduce that UML is a language, unified modeling language. This is used for each and every part of software engineering. So if you are aware of this will be very helpful in understanding these discussions. So there are elements of analysis model. First of all, we have discussed scenario based model. Then we have class based model. That means this is implied by the scenarios. Then we have behavior elements, which is state diagrams for example per se, and then the flow oriented these elements, that is data flow diagram, DFDs. Then use cases. These are very important, use cases, because these are a collection of user scenarios that describe the thread of usage of a system, right? Use cases. So each scenario is described from the point of view of an actor and a person or a device that interacts with this software in some way. So this use cases becomes very important. Then each scenario answers the following questions. Who is the primary actor? The secondary actor or actors? What are the actors' goal? The precondition should exist before the story begins. The main task or functions are performed by the actor, and what extensions might be considered as the story is described, and what variations in the actor's interactions are possible, and what system information will be, or will the this actor acquire, produce, or change, and will the actor have this have to inform the system about the changes in the external environment, and what information does the actor desire from the system, and does the actor wish to be informed about unexpected changes? All these these are very less. There are so many scenario and answers and questions you need to go through. This is an example of use case diagram. This is a home owner and this is an actor, and there may be an actor called system administrator. Now it is dealing with this arms and dispatch system, accesses system via internet, and it responds to alarm event and encounters an error condition. So there are various things when dealing with the other part like sensors, but this is how a interactor like actor will interact with the system. And as far as system administrator is concerned, it will what role does he have in this particular scenario. This reconfigure sensor and related system features. Let us introduce a system called safe home system. What it says, you have a sensor and it has maybe if you are an object oriented person, then maybe it may be a class, and this is a sensor. You have name, type, location, area and characteristics, and you have functions to identify, enable, disable and reconfigure. And these are the state diagrams. You have a state name, state variables and state activities. The state name may be reading and command. State variables may be status system is ready, display message is enter command, display status is ready. While these state activities can be entry, do this, do that, and these are this do or type of actions or some event, they come under the state activities. Then we have this analysis pattern. What it can be, you have this pattern name, the descriptor that captures the essence of the pattern. Then you have intent that describes what the pattern accomplishes or represent. Then you have motivation, that means a scenario that illustrates how the pattern can be used to address the problem. And forces and context, solution, consequence, design, known uses and related patterns. They all come under analysis patterns. Then negotiating the requirements. This is also an important aspect. You have to identify the key stakeholders. That is those people with whom you are going to be negotiating. And people are very important because ultimately software are made by people for people, and determine each of the stakeholders win conditions. When always try that there has to be a win-win situation of yourself and the stakeholders. Then negotiate, work hard or work toward a set of requirements that lead to win-win. Then comes the validating requirements, because validation is very important. Whatever you do, if you don't validate, if the customer finds some bug or problem, then your software is, or the work, all the work you are putting into, they are worthless. So validating requirements means if or is each requirement consistent with the overall objective of the system or product? Have all requirements have been specified at the proper level of abstraction? That is, do some requirement provide a level of technical detail that is inappropriate at this stage? And is the requirement really necessary, or does it represent an add-on feature that may not be essential for the objective of the system? And if each requirement bounded and unambiguous, means it is clear, then does each requirement have attribution? Means that a source, that generally a specific individual which is noted for each requirement. And do any requirement conflict with other requirements? This is also important. These are the validating requirements, but we still have some more. That is each requirement achievable in the technical environment that will house the system or product? And if is each requirement testable once implemented? And does the requirement model properly reflect the information process function behavior of the system which is to be built? And has the requirement model been partitioned in such a way that exposes progressively more detailed information about the system? And have requirement patterns been used to simplify the requirements model? And have all patterns been properly validated? Are all patterns consistent with the customer requirements? So this was an idea about understanding the requirements, and we will be covering this requirements, modeling, scenarios, information and analysis classes and much more in the later session. Thank you so much. Take care of yourself.